Hello all. In this video, we are going to learn about the architecture of 8085 microprocessor. So this is the internal architecture of 8085 microprocessor. So here we have the accumulator, which is nothing but the A register, temporary register, which is used to store the temporary data. Arithmetic logical unit is used to perform the arithmetic operations and the logical operations. So we have the flag register or the flag flip-flop, interrupt control, which is used to provide interrupt to the device. So INTR interrupt, INTA, which is nothing but the interrupt acknowledgement, RST reset 5.5, RST reset 6.5, RST 7.5, and the trap signal. So these are like providing the interrupt to the device and stopping the interrupt and acknowledging the interrupt. So serial IO control, so which is serial input data and the serial output data. So next one is the 8-bit internal data bus, where the data will be transferred, inside the device. Instruction register is used to store the instructions in the device. So instruction decoder. So a decoder is usually used to decode the data while sending the data to another peripheral device, maybe a stepper motor or another interfacing device, and the machine cycle encoding. So the encoding process and the decoding process is performed in the instruction decoder and the machine cycle encoding. So next one is the timing and control unit. So where we have the clock signal, generation signal, clock out signal, and the ready signal. So RD is used to when RD is 1, okay, when RD is 1, the device will read the data. When WR is 1, the device will write the data. ALE, ALE, S0. S0 is nothing but the status signal. S1 is also the status signal. IO/M bar is input, output, and the memory bar. So when we are reading the memory, then the data would be M bar. Hold is nothing but the hold signal. HLDA is the hold acknowledgement. Reset in is resetting the input. Reset out is resetting the output signal. So here we have the multiplexer. We have registers like W register, Z register, B register, C register, D, E, and HL registers. So stack pointer will always use to point to the data which is there in the top of the stack. Program counter, incrementer and decrementer address latch is there, which will increment the data by 1 and which will decrement the data by 1. Address buffer is used to store the address. Okay. So address will be traveling in the address bus and the data will be traveling in the data bus. So the internal architecture of 8085 microprocessor determines how and what operations can be performed with the data. And it is used to store the 8-bit data, perform arithmetic operations and logical operations, and sequence of instructions can be executed in the 8085 microprocessor. So we have registers. We have 6 registers, as I told already. So one is a B register, C, D, E, H, and L registers. So these individual registers can be used to store 8-bit data. When we want to store 16-bit data, we have to use BC, DE, HL registers to perform the 16-bit operations. So accumulator is nothing but the A register, which is used to store the 8-bit data. This is used to perform the arithmetic and logical operations. So next one is a program counter. So this 16-bit register deals with sequencing the execution of instructions. This register is nothing but the memory pointer. Memory locations have 16-bit address. The microprocessor uses this register to sequence the execution of the instruction. The function of the program counter is used to point the memory address, as I told you already. So this program counter is used to point to the memory address from which the next byte is to be fetched. So next one is a stack pointer. So the stack pointer is also called as a 16-bit register, which is a memory pointer. It points to the memory location in a read and write memory, and it is called as a stack. Timing and control unit. So this unit synchronizes all the microprocessor operations with the clock and generates the control signal necessary for communication between a microprocessor and the peripherals. The control signals are similar to a sync pulse in an oscilloscope. So we have instruction register and the decoder. So the instruction register and decoder are part of the ALU. We have array registers. There are two additional registers called temporary registers, which are nothing but the W and Z registers. We usually include these registers along with the other 8-bit registers. Next is a multiplexer and a demultiplexer unit. So which is used to combine the data and demux or uh, decombining the data. So this unit is used to select a register out of all the available registers. This unit behaves as a multiplexer when data going from the register to the internal data bus. So the demultiplexer performs is operated when the data is coming to the register from the internal data bus of the processor. So next one is the address buffer. Next is the data buffer, which is used to store the data. And the incrementer and decrementer would be used to increase the data by 1 or decrease the data by 1. So I hope you would have found the video to be useful. See you in the next video. Until then, it's bye from Radhika.